Hey everyone, notes 4.2 are on rational exponents. So essentially what this means is what happens if we have fraction exponents, because that's what a rational value means. So fractional exponents are synonymous with rational exponents. So what we're going to do is we're going to look at a cube with a side length of x. So question number 1 says to draw a picture to represent this situation. So I'm going to draw my cube right here. Okay, and I know that my side length is x, which means that all the sides are all going to be the same because it's a cube. So question number 2 says to express the area of the base in terms of x. Well, my base is a square and each side is x, so that means that my area is x times x, or x squared, and that's where the term. Question number 2 says to express the area of the base in terms of x. Well, right here, if we know all the base is going to be a square and we know all the sides are x, so the area of the base is equal to x squared. Okay, question number 3 says to rearrange this equation to represent the side length in terms of b, which is the area of the base. So essentially, all it's just saying is to isolate x, okay? Well, if b is equal to x squared, then in order to get rid of this square, I have to square root this x squared. So I end up getting just x to the power of 1. But whatever I do to one side, I do to the other side. So therefore, x is equal to the square root of b. Okay? But one thing that I want you guys to realize is I want to write this out with an actual exponent instead of a radical. So I'm going to go back to my original equation, which says b equals x to the power of 2. And if you guys remember, if there's no exponent here, it means that there's an exponent of 1, okay? So what I want to do is I want to make this x to the power of 1, because when I'm isolating here, I want to know just what x is, not what x squared is. Well, how do I change a 2 into a 1 and be able to do the same thing on the other side? What I can do is I can divide by 2. So instead of writing divided by 2, I'm going to make this 2 over 2, because 2 over 2 becomes 1. But if I'm going to do it to this exponent on this side, I also have to do it to this exponent on the other side. So I end up getting b to the power of 1/2 is equal to x. So x is the same thing as the square root of b, or b to the power of 1/2. So what conclusion can I make? Square rooting is the same as raising to the power of 1/2. Okay? All right, so let's try another similar example. Number 4 asks us to express the volume of the cube in terms of x. So the volume of the cube is length times width times height, or x times x times x, or x to the power of 3. This is called x cubed because it represents the volume of a cube. Okay? And then part 5 says to rearrange this equation to represent the side length in terms of v, the volume of the cube. So here, again, it just means to isolate x. Well, if my equation is v equals x to the power of 3, to get rid of this cubed here, see how when we had a squared, we got rid of it by square rooting right here? And when we square root, we actually have an invisible 2 here, but we don't show it. So those of you guys who use your iPhone calculator apps, they always actually have a little 2 in the corner because you're taking the square root, okay? So when I want to take if I have x to the power of 3, I want to take the cube root. And the way I write that is with a little 3 in the corner here. So essentially what this means, like if I wanted to take the cube root of 8, what it means is what times itself 3 times gives me 8. So the answer to that is 2, because 2 times 2 times 2, 3 times gives me 8, okay? So that means that the cube root of v is equal to x, or x is equal to the cube root of v, okay? But same thing, I want to write this out with exponents instead of radicals. So if v is equal to x cubed, I'm going back to my original equation here, and I want to end up getting x to the power of 1, what do I have to do to this 3 to make it x to the power of 1? I have to divide by 3. But I also have to divide this exponent of 1 by 3. So that means that I get v to the power of 1/3. So x is equal to v to the power of 1/3. So what's my conclusion here? I can say that cube rooting is the same as raising to the power of 1/3. And I can do the same thing with any power, right? So if I want to take the 4th root, it's the same thing as raising it to the power of 1/4. If I want to take the 10th root, it's the same thing as raising to the power of 1/10. So what's my conclusion? My conclusion that I can make is that if I'm going to take the nth root of x, that's the same thing as taking writing x as x to the power of 1/n. So essentially, if I have x to the power of 1/n, it means to take the nth root of x. Okay, so let's do a couple examples. 49 to the power of 1/2 just means to take the square root, the second root of 49. So this means that I want to take the square root of 49, which is just 7. This right here says -8 to the power of 1/3. This means that I want to take the cube root of -8. So what times itself 3 times can give you -8? So -2 times -2 is +4, and then multiply that by -2, and I end up getting -8. So that's my answer. My answer will be -2. Okay? And then lastly, right here, we've got 10,000 raised to the power of -1/4. So first of all, if I have a negative exponent, that means I need to do the reciprocal of this value. So it's 1/10,000 raised to the power of 1/4. So what this means is I have to take the 4th root of 1/10,000. Well, 1 multiplied by itself 4 times is going to give me 1. And then if I take 10 and I multiply it by itself 4 times, I would end up getting 10,000. So it's 1/10. So remember, 2/3 just means 2 sets of 1/3. So it's 2 times 1/3. But when I'm multiplying, I'm allowed to change the order. So I'm allowed to say that it's 1/3 times 2 right here. Okay, so if I end up getting 8 to the power of 2/3, I'm allowed to say that essentially it's just 8 to the power of 1/3, and then that whole value is going to be raised to the power of 2, because when I have 1/3 if I have a power raised to a power, I multiply these values together, and when I multiply them, I get the 2/3 that I want. Now, if I have 8 to the power of 1/3, we just figured out that that means that I'm going to take the cube root of 8, and then with the squared on the outside, I'm going to raise it to the power of 2. So what's the cube root of 8? What times itself 3 times gives me 8? That answer would be 2. So this ends up being 2, but the whole answer has to be raised to the power of 2, so I end up getting 2 times 2, which is 4. Okay, and it would work the other way around as well. So let's say instead I decided to do 8 to the power of 2 first, and then raise that answer to the 1/3 power. That means that I would end up getting 8 to the power of 2, and then I would take the cube root of that answer. Okay, well, 8 to the power of 2 is 64. 8 times 8 is 64. Then I would take the cube root of 64. Basically, what times itself 3 times gives me 64, and 4 times 4 times 4 is 64, so my answer is 4. Now, I personally would rather do the cube root first and then do the power of 2 because I'd rather take the cube root of a smaller number as opposed to a larger number, but it's 100% your choice what order you'd like to do it in. So it's really important that you guys understand that what this is saying right here is that I am taking the nth root of x. So I'm taking the nth root of x, and then I'm raising it to the power of m. So that's what this means. Or I'm allowed to do it in the opposite order. I'm allowed to raise x to the power of m, and then take the nth root of that answer. They're both saying the same thing. So here's an example right here. This is saying that I want to take the cube root of 27 and then square it. Or I can square 27 and then take the cube root of that answer. Now, I personally would rather take the cube root of a much smaller number, 27, than a larger number. So that's how I'm going to do it. But again, like I said, it's your choice. So what this is saying is I'm taking the cube root of 27 and then I'm going to square it. Okay, well, the cube root of 27 is what times itself 3 times gives you 27, and that's 3. So I end up getting 3, and then that's being raised to the power of 2. So my final answer is 3 times 3, which is 9. Okay, so if I'm asked to evaluate negative 27 to the power of 4/3, this third part right here means I have to take the cube root of negative 27, and then this 4 up here means I have to do to the power of 4. Okay, so the cube root of negative 27 means what times itself 3 times gives me negative 27, and that answer is negative 3. And then I'm going to take negative 3 and raise that to the power of 4. So I'm going to take negative 3, multiply it by negative 3 4 times. Well, negative 3 times negative 3 is positive 9. Negative 3 times negative 3 is also positive 9. So my final answer here is 81. Now, remember we said you could do it the opposite way if you want to. So instead, if you would rather raise it to the power of 4 first, I could say that my answer is negative 27 in brackets, because that's my base, raised to the power of 4, and then I would take the cube root of that answer right here. Okay, so I'm going to take negative 27 and multiply it by itself 4 times. So I'm going to take negative 27 and, we're going to take negative 27, raise that to the power of 4, and we end up getting 531,441. So this means I have to take the cube root of that value that we had here. And then when I do that in my calculator right here, I'm going to need to raise it to the power of, in brackets, 1/3 in my calculator. So I know that full piece is my exponent. Press enter and I'll get 81 as my answer. Okay, so again, I would much rather do it this way because then I don't have to deal with such large numbers. All right, the next one that we have here is 16 raised to the power of negative 0.75. Now, we could evaluate it with a decimal, but it's better for us to evaluate it as a fraction because then we actually understand where these numbers are coming from. So I end up getting 16 to the power of negative. Now 0.75 is 3/4, right? So it's to the power of negative 3/4. Well, if I have a negative exponent here, that means that I need to do the reciprocal of my base. So if my base is 16, then I'm going to do 1/16 raised to the power of 3, positive 3/4. Okay, so what does this mean right here? This over 4 piece right here means I have to take the 4th root of 1/16. And then this power of 3 up here means I have to cube that answer, okay? Well, the 4th root of 1 is just 1, and the 4th root of 16 is 2 because 2 times itself 4 times. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 times itself 4 times is going to be 16, and then I have to raise that to the power of 3. So I end up getting 1 to the power of 3 over 2 to the power of 3, which ends up being 1 over 2 to the power of 3 is 8. So my answer here is 1/8. Okay. Now, our last example looks very complicated, and it is a little bit trickier. You're going to want to write small because there are a lot of steps that we're going to need to do here. But once we finish it all up, it's actually going to end up being a nice simplified number. So the first thing I'm going to do is I'm going to take 8 to the power of 5 over 6, and I'm going to leave it as 8 to the power of 5 over 6 for now, because I have a bunch of bases of 8, and I want to rewrite this as a single expression with just one base. Just like this is one base, this is one base, but I've got a bunch of different bases here. Okay, and I'm actually going to rewrite this square root of 8 right here as a base of 8 with an actual exponent. So if I'm taking the square root of 8, it means I'm raising it to the power of 1/2. Okay, and then that's all going to be over 8 to the power of 5/3. Then we're going to use our rules to do our evaluating. So right here, when I have multiplication, I want to add my exponents, okay? So over on the side right here, I'm going to actually do my addition. So I'm going to take 5/6 and I'm going to add 1/2 to it. But I need it to have a common denominator. So my common denominator would be 6. So I multiply numerator and denominator for the 1/2 by 3. So I end up getting, I'm going to copy down this 5/6 as is, and then 1 times 3 is 3, 2 times 3 is 6, right? So it's just 5/6 plus 3/6, which ends up being 8/6. But I can reduce that, so I would end up getting 4/3. Okay, they're both divisible by 2. So I end up getting 8 to the power of 4/3 divided by 8 to the power of 5/3. Well, when I divide, I need to subtract my exponents. So it ends up being 4/3 minus 5/3, which ends up giving me here, at least I have a common denominator, so that makes it easier. I get -1/3. So I get 8 to the power of -1/3. Well, if I have a negative exponent, that means that I want to do the reciprocal of my value right here. So essentially what this ends up being is 1 over 8 raised to the power of +1/3. Okay, so since it's to the power of 1/3 right here, what this means is I have to take the cube root of 1 over 8. And remember, I can do each part separately. So take the cube root of 1, I end up getting 1, and the cube root of 8, I end up getting 2. So this whole crazy, wacky problem right here ends up simplifying to become 1 over 2.